Joelle, whenever, okay, is it good to start? Fantastic. All right, good evening, everyone. It's so nice to see all of you here. Welcome to the Department of Architecture's lecture series at MIT. My name is Caitlin Mueller. I'm a faculty member here in the department, and I'm currently the director of the Building Technology Program, who is very thrilled to be hosting tonight's lecture. And before I introduce our speaker, I'd like to start with our land acknowledgement. MIT acknowledges Indigenous peoples as the traditional stewards of the land and the enduring relationship that exists between them and their traditional territories. The land on which we sit is the traditional unceded territory of the Wampanoag Nation. We acknowledge the painful history of genocide and forced occupation of their territory, and we honor and respect the many diverse Indigenous people connected to this land on which we gather from time immemorial. And now I'm really thrilled to introduce our speaker, Professor Vivian Loftness, who, as many of you know, is an alum of both our undergraduate program in the Bachelor of Science in Art and Design and also the Master of Architecture program. I just recently learned that this was the 50th anniversary of Vivian's graduation from MIT, so she was actually here in June or in May for our commencement, where she was wearing a red jacket with her graduating class. And so welcome back again, Vivian. It's so wonderful to be here. And Vivian also recently just told me that there were, in her graduating class of 1,000 students in 1974, there were 80 women. So she was one of 80 women out of 1,000. Our proportions have changed since then. But since graduating, she continued actually at MIT in the Master of Architecture program, and then went on to have an incredibly illustrious and inspiring and very highly impactful career in architecture and building performance. So immediately after graduating, she won a scholarship from the Rotary Club to go to Finland, where she was, well, I don't exactly know what you did, but I'm sure it was super interesting and related to architecture and building performance. And then she returned to the United States, where she worked for the AIA's, the American Institute of Architects Research Group in Washington, D.C., and then was quickly swept back up into teaching in academia, where she's been teaching in various prestigious universities in environmental systems and environmental performance and in design and in studio and in sort of the integration of all of these facets for over 40 years. She's currently university professor at Carnegie Mellon University, the Paul Mellon Chair, and the former head of the Carnegie Mellon Department of Architecture. She's an internationally renowned researcher, author, and educator with over 40 years of experience in building science research for industry and government. In addition to editing the 2013 and 2020 Springer Encyclopedia of Sustainable Built Environments, she has authored books, research reports, and chapters on climate and regionalism in architecture, environmental design, and sustainability, advancing building systems integration and design for performance in the workplace of the future to enhance productivity, health, and the triple bottom line. I'm not going to read the rest of her extensive biography, which is incredibly impressive, but as you'll see, I think, in her talk, she's had a huge impact not only in the education of generations of students, but also really in working directly with practicing architects, with federal agencies, with the United States government to advance to a very substantial degree our understanding and abilities to improve the life cycle performance of the built environment, which is more critical than ever in the context of our climate crisis that we now understand to be in. I think we're all going to find quite a lot of inspiration from Vivian's talk, and I hope we all have an exciting discussion afterwards where we'll have time for a few questions and answers. With that, please join me in welcoming our speaker, Professor Vivian Loftness.
So I'm assuming I'm loud and clear. Okay. I'm going to pour information at you. So I'm hoping you'll just sort of lean back and let it just sort of flow through your head, and whatever sticks is going to be important in some way, hopefully, to all of us. I'm here to talk about balancing advanced technologies and natural technologies in both the urban environments of the future and the buildings of the future. I'm going to introduce two words: mitigation and adaptation, which I'm sure 2/3 of this audience knows well. We obviously, with the hurricanes that have been flooding the Carolinas and Florida, I mean, the states, just looking at the news every day makes us very aware that as professionals, we have to design adaptive environments. And then at the end of the lecture, I'm going to talk about how we have to mitigate against the climate change getting even worse. So let's talk about adaptation. I have had the privilege of working with two leading professionals, Bert Gregory from Methuen Architects and Alistair McGregor from OV Arup San Francisco on a resilient zoning strategy, the imperative of what we have to do in the land use and in urban design with, to address resiliency and to ensure equity. And you can see here quickly a definition of climate resilience, and of course the two major challenges are what's known as chronic stresses, or things that are weaken the fabric of a city on a day-to-day and cyclical basis, and then acute shocks like a hurricane, which are sudden and sharp events that threaten a city. And those two variables have created the need for us to rethink our land use and our buildings. We've crowdsourced at Greenbuild over 3 different time periods, over a 5-year period, with some of the leading professionals from all over the country, in some cases all over the world, on what do we have to change in our built environment to ensure resiliency and equity. And we broke them into 7 big clusters: water, energy, food, waste, mobility, human health, and ecological health. And I'm going to just quickly go through those to talk about it. So water resilience, what could possibly go wrong? There are at least 3 different variables that we have to design for. One is deluge, which of course is deluge rain as well as rising water. Second is drought, and the third is contamination. And all 3 of these are pervasive in the world around us. The important thing is to actually establish principles for design. So we've actually, through the crowdsourcing, not only set principles, we've actually set some priorities. And we're in the process of trying to create the book that would capture all of these good thoughts. Resilient cities and communities will live on their own water resources and thrive by minimizing water demand, maximizing rainwater capture and reuse, and optimizing a suite of gray and black water capture for highest reuse with equitable reliability and affordability and without toxic waste. So there becomes a guiding principle. What it ends up meaning is that we require that all new development stay clear of the 2050 100-year floodplain. In other words, we no longer develop in floodplains. And we actually start to redevelop things that are in 100-year floodplains. Unless they're incredibly historic cities like New Orleans, we need to begin to help these cities move and relocate. And this is an example in Oregon of a town that was completely devastated by heavy rains, and the new town that has been built since then. We would require that recycled water only is used for irrigation and toilets and fire suppression and cooling towers, which, by the way, is a huge amount of water that we use right now, this water for, right? Potable water, the thing that we need to drink. And we would incentivize a network of district or neighborhood black water systems so that you actually process black water locally instead of shipping everything back to a central sewage plant and a central water processing plant. And I just want to tell a little bit of the illustrations. The profession is so far ahead of academe. They are absolutely embracing these standards. And this is an example of Phipps Conservatory, which is a living building in Pittsburgh designed by the Design Alliance with CJL Engineering and Andrew Pogan for landscape and CEC for civil infrastructure and Turner Construction. By the way, it takes a team to make a resilient solution. It is never the architect alone. It is always the collaboration from the outset that makes these projects. This net zero project captures all of its own on-site water. It uses all of its gray water and the storm water for all 4 of those things that we just talked about. And it captures its own sewage and processes it back into gray water as well. So it's a closed loop system that's truly an innovative contribution. Just a few more examples of the water solutions that are out there. This is city of Portland and how they cope with very, very heavy storm. Every sidewalk is a water storage system, right? Every time you design, you anticipate heavy rainfall, and you design things that can ebb and flow, and the water can rise and fall, and it completely transforms the quality of the street, the walkability of the street in the process of solving a major, in this case, deluge water problem. In terms of the water processing, this is another example, Dockside Green in Victoria, Canada, a beautiful new development where they became the water and sewer authority in a new development for the region. So they got major resources from the state to actually build the water and sewage system, which actually underpins a beautiful development where the water, the creek that runs all the way to downtown Victoria is literally a cleaned gray water and black water system. The second major challenge that we're trying to deal with is energy resilience, and we want to deal with this with equity. So what could possibly go wrong? Here you're looking at a major pipeline from the tar sands in Canada that's running right through Indigenous territory, talking about honoring your Indigenous populations, nothing like cutting right through territory we don't actually even own. What could possibly go wrong? Well, we know we have significant energy insecurity. On the one side, people who cannot afford to pay their bills or actually are in areas that don't have adequate access to energy. And then we have energy waste, which is those of us who've not yet figured out quite how to cut down on our demand, even if it's not needed. We've got significant issues of energy reliability and grid failure, and we've got a peak energy challenge that's going to even get worse as we try to electrify all of our buildings, which is really the agenda that's on the table right now. The principle is that resilient cities and communities will be carbon neutral, and they will thrive by minimizing energy demand, maximizing natural conditioning and walkability, and optimizing a suite of district electric and low temperature thermal energy sources with building load balancing. We really have the potential here to become transformative as players in the built environment. The rules that come out are requiring energy and essential services to be able to survive shocks. So we're bringing our equipment out of the basement and up onto the roof. We're actually providing safe harbors for crisis moments where you actually have places to go, whether it's the library, the recreation center, or the school. This for San Francisco. All buildings that are now off-grid or capable of being off-grid, so you have a place, a safe harbor to go to. We're looking at buildings that do grid and integration. So we're generating power locally, we're storing it and using it locally, but we're also feeding it back into the grid. So it's a two-way grid. So every building becomes part of the source solution for the future. Incentivizing building for daylighting and passive solar heating and passive cooling and ventilation. And we're going to start to zone so that we have critical mass to make walkability and mixed use viable. This is where I live and work. This is called the intelligent workplace. We get a lot of razzing about this because they think, why do you get to call it the intelligent workplace? Do you think we work in the stupid workplace? We go, no, it's just called that because it took a team to create the level of learning and a living laboratory that we need to teach about the future of building systems and systems integration. There's a team of us in the Center for Building Performance that were part of the design team. We worked directly with a consortium of industry players who really knew a lot about glass and networking and lighting. And then we had Pierre Zulli out of Switzerland, BCJ, Bowen Chwinski Jackson out of Pittsburgh, and then Ray Engineering and TEDCO for construction. It took a team to make a living laboratory. It's not a big lab. It's about 7,000 square feet. It houses about 35 graduates and faculty, and we basically study the next generation of building systems for energy. Number 3, food. What could possibly go wrong? Well, number 1, we have significant diet and food insecurity. We've got an inadequate access to healthy foods for many neighborhoods. We've got food toxicity with more than 1 in 6 Americans getting foodborne sicknesses every year. We've got substantial food waste. Over 40% of our fresh and processed food goes into landfill. So we have these substantial challenges. The question is, what are the principles we should be designing for? Well, resilient cities and communities will be able to thrive on their own food resources, catalyzing changes in demand by maximizing local food production and preparation, minimizing food waste, and ensuring equitable access to healthy foods without toxicity. So we have some principles. What does it mean in terms of our design solutions? Well, maybe it's time for all cities to have urban growth boundaries. Now, these have not been adopted beyond probably maybe 50 cities in the US. They started most of Oregon, and big chunks of the state of Washington have urban growth boundaries. These are edges to where you can actually develop. And they're basically designed and scaled to maximize density and mixed use within the growth boundary and keep the agricultural lands and the forests intact. And every city that has adopted an urban growth boundary has found vibrancy coming back to the city. Developers, they fight it tooth and nail. They've actually tried to take the state through the courts many times, but they can land on their feet. They all of a sudden realize, well, I can take that old shopping mall and turn it into a whole new place. I can take that empty parking lot, I can rezone and redevelop. And so Portland today is a totally different city than it was 30-some years ago when the urban growth boundary went in place. And it really was transformative. It's time that we actually require citywide zoning to accommodate urban food. We need urban food because it's the only resilient solution. This is a wonderful master's thesis from Eleni Katrini at Carnegie Mellon. She gathered case studies of how much food you could grow in our climate. In this case, you're looking at a Queens roof where they, on less than an acre, they were able to grow 7 tons of food, which would service quite a substantial number of fresh food requirements for a neighborhood. On this project in Brooklyn, on 4 acres, they were able to grow 12 tons of food. And in this project in downtown New York, they were able to on less than, on 0.03 acres, to do 60% of the restaurant's needs for fresh herbs and vegetables. And this, of course, is an advanced technology, hydroponic, that you can now do in even less land. So we've got the potential for our cities to become food sources that are healthier. Again, the design community is way ahead of us. This is Chatham's campus outside of Pittsburgh called Eden Hall. It's their sustainability education campus. It's a closed-loop food, water, and waste campus, so they can live entirely within the boundaries of the campus itself. It was designed by Methuen Architects with BNIM and Interface Engineering, CEC Civil, and Andropogan Landscape with Biohabitats as the consultant. You'll start to see these names repeat themselves. These are firms that are absolutely leading the way in which food is and landscape is transforming our built environment. It's a beautiful campus where they do grow all their own food. They also have fishery that uses the waste. The fish provide fertilizer for the vegetables, and of course on-site PV, daylight, natural ventilation, a beautiful campus with on-site training on how to serve local food. It's so delicious. It's such a fabulous venue to go out and eat or meet at. Beautiful project. Number 4, waste. What could possibly go wrong? Well, one, we've got some substantial waste toxicity. All of us, unfortunately, there's a point at which every computer ends up becoming obsolete. It becomes part of the waste stream. We don't have really a way to take it apart and reuse all the good parts. And so we have to toss the whole thing. We've got significant poor sanitation problems because of combined storm sewer. So we're essentially flooding our waterways with sewage in heavy rains, which is really bad, which of course is now illegal, but cities are having a hell of a time trying to solve this. And we've got lost resources. About 25% of our waste is actually recycled in the US, whereas in Europe it's well over 65 or 70%, and in Scandinavia it's 100%, because what they cannot repurpose, they actually turn into energy. So waste to energy is a standard process in most of Scandinavia as a way of becoming independent from fossil fuels. So what are the principles for waste? Resilient cities and communities will neither landfill nor export waste. They will instead treat the waste stream as an invaluable resource in a cradle-to-cradle commitment to waste as industrial and/or agricultural nutrients. I'll come back to that. Let me just end there. You guys may all notice this is a waste-to-energy power plant in Copenhagen, designed by the big group, and it literally is also used as a ski slope. I mean, it's an amazing building, and it's all about the infrastructure for a city. And the advantage of having waste heat generation in your city is that you can run thermal loops that provide free heat for the city. You're generating power and thermal energy, meeting the heating loads of the buildings, providing power, and in this case, providing a recreational facility for Copenhagen. Nearby in Stockholm, you actually have a waste infrastructure that generated a 20,000 household community on a brownfield site right across the waterway from Stockholm. And this one uses a vacuum tube system to separate recyclables, which, you know, they have a bottle day, they have a paper day, they have a compost day, and everything gets suctioned across and actually is processed in the community, providing local jobs to produce raw glass material and fertilizer, and they literally are taking this into productive materials. What they cannot use here, they take to the central waste to energy power plant, and then they have a thermal loop that takes makes that more efficient. Here's the community. The last time I was in Stockholm, I stayed at an Airbnb in Hammarby because I wanted to see this whole brand new community that's designed around waste and how you make waste into a positive community. It's a beautiful destination. It also does a huge amount with water and water management. Beautiful destination. If we're serious about waste, we're going to have to incentivize long life buildings and long life building materials, because obviously we're tearing down buildings too quickly. We're not using them to the hundreds of years that they should be designed for, and we need to incentivize flexible and convertible buildings. The designs have to be able to support change. Office buildings are no longer needed to the level they were before COVID, and now what are we doing with them? Are they capable of becoming housing? Are they capable of becoming dorms? So how are we incentivizing the design for flexible and convertible spaces? And what are the design changes? Not just how do we incentivize it, but what does it do to our structural grid? What does it do to our floor-to-floor height? What does it do to the access to outdoors? All of which are going to be important if we want it to be survived. We also need to incentivize historic preservation and adaptive reuse of historic buildings. This is just one example of a beautiful project in Seattle. Number 5, mobility. What could possibly go wrong? This is a fraction of the millions who tried to leave, in this case after Hurricane Rita. Just imagine after Hurricane Helene or Milton, which all happened in the last few weeks. So ultimately you see gridlock of people trying to get out. There is no mass transit in this state. There is no other alternative for getting people out of this state. This is not sustainable. This is not resilient. We've got significant challenges with congestion and gridlock because we've been so car-centric for so long that we don't have a commitment to the alternative of cars. We also have inactive lifestyles. Children spend 5 to 7 hours a day in front of screens, computer screens and TV screens, because they cannot get to the playground. They cannot get to the community activities or the after-school activities, and the parents are working and can't be driving them back and forth. We've literally let the car turn our lives upside down. And we've got at least 25% of the American population that's too young, too old, or infirmed and cannot drive a car. So a quarter of the population, if we don't have sidewalks, if we don't have transit, are essentially immobile. So what are the principles? Well, resilient cities and communities will ensure equitable access for all citizens to basic quality of life services and infrastructures through mixed-use density, design for walkability, bikeability, and transit, and ensuring safe and environmentally rich connections to promote active lifestyles and reduce car dependency. It can't just be the sidewalk. It has to be a pleasant sidewalk. It has to be a well-engineered sidewalk with a tree canopy that's not going to be baking in the heat of the day. So what we see happening and what the design firms are meeting is compact, what's known as transit-oriented development, mixed-use communities that are compact. And you see this in a lot of different standards, and you certainly see it in certain cities' codes, and in this case in Seattle, where they incentivize as much development wherever there's a transit node. They also have begun to incentivize safe, connected green spaces that cut across development, so it's owned by multiple developers. with tree canopies and protected bikeways and walks and traffic calming and stormwater management and biodiversity. So all of a sudden we're seeing things swaths. And I know there's some amazing projects that are going on in the Boston area to create a continuous green path down some major roadways. One of the most interesting communities that is designed around transportation and mobility is Vauban in Freiburg, which was an old army barrack, a French army barrack for many years, and then was abandoned like many of the army barracks throughout Germany. In this case, they went back and put infill housing and converted the army barracks into housing by really looking at what needs to be within walking distance, what can be in light rail distance, and what can be in high-speed rail distance, and then really designing around those distances. It is the highest biodiversity in Germany because they took the cars out of the heart of this development. They have a feeder road. You can drive in to drop off groceries and an elder family member, but by and large, you park your car in a structured garage and you walk. And that way, the kids own the streets, the kids own the greenways, and the greenways are pervasive. And it's just an amazing project, including the light rail that runs on a greenway. And it's the highest density of children in Germany because family with small kids heard about this development and all started to emigrate to Freiburg because they wanted to live in a place where the kids could run out directly from the house into greenways, down to a creek, to horses, and it's just an amazing, amazing center. And there are a lot of seniors there too because it's a vibrant community where you feel like you're in a multi-generation living together. Number 6, human health and safety. What could possibly go wrong? Well, number 1, we've got natural disasters, but even if we didn't have the disasters, we have aging infrastructure that is, as the American Society for Civil Engineers have said, they would give us a D+ on the condition of America's infrastructure. We sprawled our way into an infrastructure that's so big that we do not have the tax base to maintain it, which is one of the reasons why urban growth boundaries are so effective, because it stops the sprawl and reintroduces density on the infrastructures that we've already built and gives us the resources to upgrade them as they need to be. We've got some significant human health issues related to heat and indoor air quality, and we've got human health issues related to outdoor air pollution. So the principles are that resilient cities and communities ensure human health and safety in the face of natural disasters and aging infrastructures, and they eliminate sources of outdoor air pollution, mostly combustion, and they protect the source of indoor air and daylight and sun and shade to ensure ensure equitable access to healthcare facilities and safe harbors. Here's an example of a project in China. OVA Air helped to engineer a city that was going to be a totally new city that would guarantee airflow through the city. So they did a lot of computational fluid dynamic analysis of the airflows and where they should be building tall and where they should be building short, where the prevailing breezes were coming from and where the street patterns should be, in order to guarantee that air would flow through the city and keep the pollution content from inversions from occurring. We would require in a zoning code that fire-resistive site planning and landscape, looking at building materials in high fire risk zones. And then there are examples like this one, the Omega Center for Sustainable Living by BNIM and BGR, engineers, Natural Systems, and John Todd. This is an amazing retreat for yoga and health that happens to be a sewage treatment plant in upstate New York. So all of a sudden, the infrastructure becomes the resilient safe harbor and the regenerative solution area. And finally, ecological health. What could possibly go wrong with our ecology? This was actually on my deck. I watched bees sort of fly in and out of a hole in the wall, and we finally took the panel off, and this bee's nest was there. Luckily, I got someone who could take the nest in its entirety down with the queen and managed to relocate it. We were so pleased to be having bees. We just didn't want the bees on our deck. We've got a problem. There's no biodiversity and no bees in a lot of our development, and we really have to address this. So we're doing regenerative design now to try to reintroduce biodiversity in bees. In the same time, we're trying to design to address global warming with all of its secondary manifestations and resource depletion. where we're using materials at a rate that is far, far faster than they can be resourced. So let me talk about those. The principles are that resilient cities and communities ensure ecological health by achieving zero carbon to reduce global warming, by minimizing the depletion of non-renewable resources in material and system selection and reuse, and by maximizing biodiversity for a robust regional ecology. So those become the principles that we want to guide. It might mean that we require citywide habitat and biodiversity corridors and connected ecosystems, which, by the way, will also solve some of our water challenges and some of our heat challenges. We're going to identify special habitat areas and pathways and nature zones that completely transform the way in which we think about development. We'd require a minimum green area factor so that we actually close the loop on water systems and increase the landing place for bees and insects and biodiverse landscape. And then most critically, and the one I'm going to move to now, which is embodied carbon and operational carbon, we have to have a maximum of acceptable operational carbon and embodied carbon for every building function in every climate. And we need to incentivize zero carbon buildings, which are zero carbon because their operational carbon is net zero, their embodied carbon is net zero, their transportation carbon is net zero, and we'll come back to the net issue, and their water associated, the water energy nexus carbon is net zero. I just want to make a point about embodied versus operational carbon. At the moment, America is so sloppy in our operational carbon that it is 5 times greater than our embodied carbon for the life of our buildings, if not more, right? So really, we have to get a handle on operational first. As soon as you've got leading professionals who've gotten their operational carbon down to net zero, and I'll come back to that, then all of a sudden, we absolutely need to focus on embodied. But if we can't get our handle on operational, it's not going to make the dent we need. We need a big dent in this carbon equation. In terms of understanding the embodied carbon, I think Cradle to Cradle and Upcycle, Bill McDonough and Michael Braungut's 2 books, are probably the leading texts on what do we have to do to guarantee that every product that we put into our buildings, I mean, I'm looking at products all around me, every product we put in the building has to either be part of a biological cycle or a technical cycle, meaning that it can actually be turned back into fertilizer or it can be turned back into another technical product. And that it's actually designed for disassembly in a way that allows us to do that. So even a product that has multiple subsects, I mean, some products like carpet, you may have a backing that needs to be separated from the front, and then it turns into 2 different cycles. We have to be able to design for disassembly. And I want my laptop to be able to be disassembled so I can just fix the 2 pieces that really needed to be fixed before I buy a whole new laptop and throw this one away. Which brings us to the challenge of mitigation. So adaptation is what do we have to do because it's all happening, and we have to design and both at the urban scale and the building scale to anticipate and to be able to survive, if not regenerate the environment. But what do we have to do to mitigate? Because buildings are a huge part of the carbon challenge. They are a huge part of why climate change is occurring. I want to make a point about this. I've had the privilege of serving on a 3-year National Academy of Science committee on accelerating decarbonization in the United States. What do we have to do to get to carbon neutral by 2050? What do we have to do by 2030 to get there by 2050? And the committee was filled with people that were not in the building sector. They were CO2 people, they were power people, they were transportation, they were industry people, they were fuel people, they were literally in every field. And I was the solo building person on this committee for decarbonization because they don't think buildings matter. Now, about halfway through, I convinced them enough that they added 1 more person. So we were 2 buildings people on this committee of 25. Here's the problem. I want you guys to look at this pie chart. It drives me nuts. There are thousands of these pie charts all over the world, including Project Drawdown and all the leaders, IECC. If you look at this, the orange wedge here is the building sector. 7% commercial, 6% residential, 13% of the problem for greenhouse gases. Now, why is it so meager? I'll tell you why. Because they have called something the electric power end-use sector. Electric power is not an end-use sector. It's a supply. It's what we're using in the end-use. But they've given the electric power because of, I don't know if you guys talked about scope 1, 2, scope 3, but if you've talked about scope 1, 2, and 3, they have separated out scope 2, which is you're not combusting it in the building, so it doesn't count in the building. It's been combusted at the power plant, and then it goes to the building, so it's given to the power plant. It's complete nonsense. Scope 1 and scope 2 should be put together. The end-use sector is buildings. As soon as I take the electric power, which is the supply, and distribute it to its end use, all of a sudden buildings are 32% of the problem. It took me a year to convince the smartest committee in the country that buildings matter. And I had to draw these charts to say, look guys, this is the transition we're talking about. Forget 13%, it's 32%. And truthfully, if you look at the industrial carbon, the percentage of industrial carbon that goes into building products, this is your embodied carbon, is about 6% of our industrial production in the US. So all of a sudden now, if I take that 6%, the buildings are 38% of the carbon footprint of this nation. It becomes a huge priority for the nation. You have to invest in buildings and building efficiency and embody both operational carbon and embodied carbon if we're serious about cutting our carbon footprint as a nation. You're going to have to make this case. All of you guys in the built environment are going to have to make this case to every audience you talk to because all they see is that first chart. And it's killing me. I can't believe that I haven't convinced people to do that. Now, so what do we have to do in the buildings themselves? ACEEE, which is the American Council for Energy Efficient Economy, is a major source of information. And they put out a, what do we have to do to decarbonize the US by 2050? And they basically said, we're going to have to cut our energy demand by 50 quads. That's a huge number. Let's just remember the word 50. I'm not making you guys memorize quads. 50 is the number. What do we do in the built environment that gets us at the 50? Number one, we do zero energy new homes in commercial buildings. As soon as we do that, we have 5.7 quad reduction by 2050. If we continue to do this, we can do 10% of what the ACEEE says has to be done for the nation to meet its commitments to the Paris Agreement. This is, I mean, Massachusetts is a leader. They've set all kinds of, landmark zero energy codes for, and it's great. California is a leader. New York State is a leader. Pennsylvania is a lagger, right? Sorry. We're not setting zero energy goals as a state or as a city, and it's critical that we do that. Can we as professionals do that? Absolutely. Leading professionals can absolutely reduce the footprint of buildings down by 70% to a 30%, and all of a sudden it can be met by renewables that are either on the building or in the community, so that's how they get to net zero. They get the loads down to 30% of where they are today. And I just want to show you, this is a HOK's incredible track record relative to the 2030 challenge. So the AIA joined a 2030 challenge. There are over 1,500 firms in the United States that have pledged to not only baseline their buildings, but to show progress year over year on everything that leaves their office, any of their offices. And they do both major renovations and new construction, and they baseline them. And so you're seeing here, this is Canada. So they're basically saying, here was our energy use index back in 2013 when we started tracking, and this is now how much reduction we have towards this target of 70%. And you can see here, every one of their offices is somewhere between 58 and 60-some%. They're literally pushing their portfolios. And now the architects are coming to the clients and saying, we could do a carbon neutral dorm for you if you will basically fund a very marginal difference for geothermal wells and PV on the roof. We're so close with our carbon footprint being so small, our operational demand is so small that we can meet it if you will actually, and of course universities are planned to be in business for the next 50 years. They should absolutely be meeting. These things pay back in 7 or 8 years. Really, you should of course be doing it. Of course, our university said, oh no, it's too expensive. We can't do the PV and the geothermal. Just give us a low energy building. So this is what the firms are doing. They're out there tracking their own. And if you guys all don't know what an EUI is, you better know before you graduate because the firms are designing to energy use intensity goals, and they're all committed. They really are, across every scale of firm. Again, once we get operational carbon in control, these firms are so close to being at carbon neutral that now they're basically focusing on embodied carbon. And they're doing that by reducing the amount of concrete they're using, reducing the amount of steel, replacing steel with wood, doing composite structures where wood becomes dominant. In Norway, buildings are measured by how many weeks of forest growth is necessary to build the building. It will be labeled a 6-week building. This whole building is 6 weeks of forest growth. And so they're really looking at the renewability of the raw materials in their building. This is a company that just started up in Maine that takes waste wood products and turns them into insulation. And instead of XPS and spray foam and even mineral wool, which are all carbon intensive, all of a sudden they're carbon sequestering, right? They actually sequester carbon. So your building can actually draw down the carbon and become a carbon sequestration system. That was another big fight I had. I did not win with the National Academy Committee because they feel we're going to have carbon sequestration that pumps our CO2 waste deep into the earth or deep into the ocean. They think that we'll never make it to the 2050 goals if we don't pump it down, which is literally taking your trash and putting it somewhere else and saying, maybe it won't come back up. I'm thinking, oh, this is not working. Let's just start to use buildings as part of the carbon sequestering future. Architecture schools very rarely talk about hardware in buildings. And yet, as a professional, you spec a lot of hardware. You and your consultants will spec your heating system, your hot water system, your lighting system, your refrigerator, freezer. If you're a grocery store, that becomes the big energy demand. Of course, air conditioning, your cooking, your clothes drying, all the plug loads that you're going to put in. Everything we put in buildings is key to us getting to low operational carbon. And there's about 5.6 quads of efficiency that we have not taken as professionals. And so, again, when all of you guys leave, you're going to be out there in the forefront of making low carbon buildings, including all the specifications that you put in those buildings. America's way behind on district and combined heat cooling power. We do have some many campuses have district systems. They're typically district steam, which is not particularly efficient and very hard to manage. When you go to Europe and you start seeing district hot water systems, these literally take a power plant and all the heat that would normally go up the chimney of a power plant, 70% of the energy in the power plant goes up the chimney. 30% is actually electricity for us. 70% is waste, which is why source energy is triple site energy, is that inefficiency at the power plant. If you can recapture the smoke that's coming out of the power plant as heat, which is easy to do, and you put it in very shallow pipes that, in this case, you can see the miles of piping in Stockholm that just takes energy from the power plant and gives it to every household for free. You just plug into the heating network from the power generator. This, again, is Hammarby. There are other examples throughout Europe. Then there is retrofits. We have a huge challenge with retrofits. There's about 3.8 quads of efficiency if we could aggressively start to make our buildings better. This is also a huge equity issue. This is the moment where we can go back and pay deference to the amount of inefficiencies and the sad condition of many poor households. This is the moment for us to literally pay back and make super efficient. Passive house is absolutely a great standard, certainly for the colder climates in the United States, because it literally takes us into extremely low energy, things that could be met with on-site photovoltaic or community PV. So we could meet the loads on the site and make carbon neutral retrofits. Smart. Now, this gets at some of the high-tech questions. I am a fundamental believer that we need both advanced technology and natural technologies. I will end with natural technologies because I really think architects, that's our command. It is absolutely true that advanced LED light bulbs have literally taken the lighting loads of buildings down to 20% of what they were. It's huge, the advantage of that innovation. Controls And smart buildings absolutely can take our loads down by a lot. You can see here, this is a federal building that we've been tracking the energy use, and you can see the building from when they had lousy controls to when they actually institute better controls. It's a huge drop in the electric demand through control technologies, right? So there's no question that smart buildings and controls is a wave for the future, and it's about 3.2 quads of out of our 50 that we can do through investing in buildings. Which brings me to nature. Before we talked about advanced technology, natural technologies is the perfect marriage. I use the term environmental surfing because surfing is fun, and because surfing does require effort, right? Surfing is not something that you just sort of, flip a switch. Surfing is something where you physically get engaged. And when you want daylight, you have to be active to make daylight work for you. Daylight without glare, daylight without overheating. Passive solar, you need to be active because passive solar is only working when the sun is out, right? So natural ventilation, which requires the windows that open. We can do natural ventilation for breathing air. We can do it for cooling. We can do night ventilation for cooling with thermal mass and time lag. All of these are passive conditioning strategies. And if we surf the environment, we can meet a third to a half of the load of the building, if not more. So let me talk about each of those quickly. In a net zero economy, architecture will celebrate climate, culture, and region, and they'll balance deep conservation with the dynamic embrace of natural conditioning. So we're literally doing super efficiency and embracing nature together. Deep buildings that are static, no change, that it doesn't matter what time of day, what season it is. Dark glass, which means they literally are trying to cut out the daylight in order to cut out the heat. These have to disappear. These buildings, by definition, they lock in a chemical soup of materials and occupant activities, and there's serious health consequences for humans, including asthma and skin and eye irritations and reproductive health and cancer. This is not the solution, these dark sealed boxes. These deep buildings also have windowless workspaces. They lock out natural conditioning resources. They don't have passive solar heat. They don't have daylight. They don't have natural ventilation. They don't have passive cooling. And they completely block out nature's renewables because nature's offering us free conditioning and we're blocking it. Instead, we'll design for environmental surfing. We'll maximize natural conditioning, which is unique to every climate. There's not a single answer that you can ship around the world. Every climate will have its own magic suite of environmental forces. And we'll use less energy, less water resource extraction, and we'll produce less pollution. We'll maximize local materials with less transportation and toxicity, and we'll reduce technological complexity with just-in-time and just where needed technological innovation. So I want the operable window and the mechanical cooling, but I want them just in time and just where needed, not everywhere and sealed. So we can environmentally surf for free heat. That can give me, in a passive house, it can give me 75 to 90% of the heating I need. It's a super efficient house. It takes very little solar energy to heat a passive house, right? So all of a sudden, I can meet the heating load, and I'm resilient. If a power goes out for 2 weeks, I'm okay in a passive house for 2 weeks. If power goes out in a badly insulated, non-airtight building with no solar contribution, I can last for about 6 hours without heat. Right? So we're literally building resiliency through nature and through efficiency. And it makes for more delightful spaces. We want to environmentally surf for light. These are 2 daylit only spaces. Okay, I'm showing you what they feel like when they're only daylight. Of course, you guys all know the MIT Chapel. On the left is a Baroque church. Those Baroque churches all predate electric lighting, so they learned how to use very small aperture because they also predate large fields of glass. So they had very small fields of translucent material, and they were able to bathe light across an entire area with very little aperture. At one point in time, we knew how to design for daylight without making it an all-glass building. So we need to rediscover the engineering and the art of effective daylight design. Daylight can displace somewhere between 35 and 75% of today's lighting, and if we rose with the sun and went to bed with the sun, we could do 100%, right? So resilient-wise, we could survive without electric light if we needed to. This is a daylit airport terminal. This is a Cesar Pelli project in Washington, D.C., and there are a few lights on because they're required by code in case, for some reason, it got too dark, just for egress, but it completely daylit. All the other lights are off. This is another airport in Paris at Orly. Again, the electric lights are off. Daylight is amazing, and it makes for far more dynamic and exciting spaces. We should be environmentally surfing for fresh air. We should not be relying on mechanical air only. We should absolutely be providing fresh air and natural cooling. And you can just see here, and just quickly talking about thermal mass, you look at the Sagrada Familia, the Gaudi's church in Barcelona, and you see a church that has a lot of exposed concrete, carefully crafted to make exciting, explosive structural elements, and they run outside air all night long through the cathedral and out the apertures of the top, pre-cooling all that mass. So when they close the doors in the morning, the space is cool enough to handle thousands of visitors the following day without a central air conditioning system. It's truly impressive what time-lag cooling can do as nature's free cooling. Of course, you have to be in a desert climate like Barcelona and big chunks of the world, but you can certainly use time-lag cooling as a natural conditioning. Natural ventilation could displace about 20 to 40% of today's cooling. Of course, climate change is making it a little tougher to displace cooling, but 70% of the breathing needs of most buildings. Classrooms designed this school in Germany, just showing you what classroom buildings that are designed around natural ventilation look like. A convention center in Cape Town, South Africa. What was really interesting about this is a convention center in Washington, D.C. that's been torn down. Pretty dumb, sad convention center. This is one that was built in Cape Town. And all of the, Cape Town does get warm, especially if you convene thousands of people at a convention center. So the air-conditioned rooms where you meet, like this kind of a lecture room, are air-conditioned, but all the circulation spaces are open air. They're protected from rain, they're protected dynamically from strong winds when it gets chilly. They let sun and light in, and so you walk out of a air-conditioned room into a thermally dynamic space. It's so rejuvenating to be able to not have to walk from an air-conditioned space to an air-conditioned space to another air-conditioned space, just literally that transition. And it externalizes a lot of the program of this building and makes nature condition 2/3 of the building. Here's another example, a shopping mall in Milan. If any of you have visited Galleria, you're looking at something that basically did not actively condition an outdoor shopping mall. I mean, they actively conditioned the shops themselves, sorry. And the shopping mall on the bottom left is in Denver, long since torn down, one of those sealed boxes where everything is air conditioned all the time or heated. We need to rediscover the possibilities of nature as a conditioning system. And here's the Sagrada Familia for night cooling. Shade is an integral part of the use of sun and light, so we need to design dynamic shading, not static shading. These are things that have to change with the time of day and the season. Trees are magical. They always know when it's too hot and when it's not hot, and they just do it all by themselves, drop all their leaves and let the sun shine through. So if we don't use trees, we need to do something that's pretty magical, that can dynamically step up and be rolled up and change by season and time of day. We want to design for open windows. To do that, I need an engineer who does mixed mode HVAC. So heating, ventilation, and air conditioning engineers. If I interviewed for a project at Carnegie Mellon, and I would do the same if I were here, I would ask the engineer, have you done any mixed mode buildings? And if they say, what does that mean? Then you say, thanks very much, and you let them leave, right? If they say, no, but I'd like to, that's at least an open door. Ultimately, mixed mode means that you're designing a mechanical system that allows you to still open the windows. This is non-trivial because most mechanical systems in the United States, which we've now exported around the world, rely on a sealed building. They rely on variable air volume air distribution to get air to every corner, and they essentially want a sealed bubble so they can blow air into the bubble, and that means you can't open the window because the air will go out the window, right? So mixed mode is the marriage, natural technology and advanced technology. If you want more information on that, I would go to the Berkeley website. Under their mixed mode, we wrote a whole section on mixed mode buildings around the world, mixed mode hotels and mixed mode lecture rooms, and it's just amazing to see what's happened. We're going to need to increase outside air because it turns out we've been starving people for breathing air. And as a consequence, people get flus and colds and COVID, and they get asthma and allergies. Everything that's in the space becomes essentially a toxin, and we breathe it in, and then we don't feel very well. So ultimately, it's becoming clear that the researchers are saying you got to blow more air. Or maybe you let people open windows, right? Maybe we do a combination of blowing more air and letting people either work outdoors or let more outdoor in. This is just an example of some of the research. You guys are more than welcome to this whole PowerPoint after this talk if you want it. You might read some of these research. We've been out trying to find the economics of low energy, high nature buildings, and this is an example where Shaughnessy found that there was a 14% improvement in math test scores in school children whenever the ventilation rate was doubled over code minimum, right? They found literally kids were just doing better at everything, right? Well, that's a pretty good argument, and you can see there's a 1,200% ROI on this because it doesn't cost much to double the air. It has an energy penalty, but $2 per student per year. We're going to provide task air. We're going to try to figure out a way to get air to the nose instead of to the bubble, because the bubble's not doing very well. The bubble will take someone with a cold in this corner, and if it's blowing from that corner, it's going to give that cold to me because I'm downwind from that. Whereas if you start to look at underfloor air, you look at ways in which or displacement ventilation where you're bringing air low, and then it plumes up, and then it returns high. That means that my cold is my cold, not yours, right? So I don't have to share it. And again, there's some good research on the importance of individual task air systems and what it does, in this case, for reducing headaches. We are definitely going to try to eliminate outgassing, so when you guys spec products, we're looking for products that do not have toxicity in them at all. We're looking for next generation natural materials that aren't bonded with formaldehyde and other things that we don't want to have people breathe. This research in Australia showed that when households eliminated formaldehyde wood products from the households that had no formaldehyde in their wood products, no composite wood, had 60% less likelihood of asthma and 63% less likelihood of allergies in the kids living in those households, which is a pretty good argument for not buying composite wood. Which, by the way, this research, which is back in 1996, changed IKEA's entire production line. This research alone convinced them, you know what, we need composite woods because it's cheap, but we're going to find a completely different way to hold those composite woods together. Research is really critically needed in the built environment. We want to give back temperature control. We are going to use smart and grid-connected controls. We really do want, I'm here, and I can remotely turn off my heat at home, right? Because I'm here. I don't need to keep the space heated to 68. I can drop it to 58 because there's nobody there, right? So there's so much we can do now with smart and connected controls. You could even let the utility control for you if they're getting into crisis with peak power. We want to make daylight dominant. We want to integrate smart LED with that. We want to separate ambient and task light. We are blasting light. Now, studios are an interesting challenge because studios, you don't quite know where the desks are going to be. So you basically blast light everywhere. So you get a uniform 500 lux on every surface. But you may not need 500 lux on every surface. And of course, it makes it a relatively bland space because it's, so if you can find ways to lower the ambient and provide task, these task lights are 6 watts. These are tiny, amazingly powerful. I can get much higher light on my horizontal surface with a task light than I can from a ceiling fixture that's way up over my head. So we're beginning to see ways in which to separate ambient and task. And again, the task light should probably have an occupancy sensor on, so when I leave the desk, that extra light just goes off because I'm not there to use it. Right? We want to maximize views. And this study was done by Heshong Mahone for the California Energy Commission. They looked at call centers and found that any call center worker that had a seated view of green space had 6 to 7% faster average handling time, meaning that they could actually process the concern of the person on the phone more effectively than their peers who did not have views of green space, which helps. This is 6 to 7% direct productivity gain in a call center, which helps to pay for a more articulated building with views of green space for every worker. And these are not particularly highly paid workers, so justifying seated views for a call center is a real advantage. And we want to celebrate sunshine. I'm sure all of you guys have seen the Bill Rahn Library at Cambridge next to the GSD. Beautiful solar irradiated daylit space, probably one of the most favored destinations of any of the libraries in the Boston region. Highly articulated facade, very interesting, double envelope facade with a lot of capability to exhaust the excess heat in the summer and recap the excess heat in winter. It's a beautiful high-tech, low-tech marriage in a single building. And then the Genzyme building, which I hear the heliostats are maybe gone. I don't know. It's been bought and sold, and if anybody in the room has been there recently, I'd like to know how it's doing. A Danish project. If you celebrate sunshine, you better celebrate shade, especially today. And that means that all of us need to start making our buildings bristle. They have to have three-dimensionality. This is not easy in the United States. This is an NBBJ development where they literally made it part of the aesthetic of the building, so it wouldn't be value engineered out of the project, right? So it's really important for us to celebrate shade along with sun. And ideally, it should be dynamic, like this. Here's the Sony Center in Berlin with dynamic shading devices and an Oculus that allows for exhaust so they can create an outdoor shopping mall. Ensuring access to nature. Outdoor, I really would love to leave you with one sort of basic agenda, which is that you should take every program that you're given in your studios and figure out how much of that program can you externalize from the conditioned bubble. How much of it can you make outside of that? Whether it's the stairwells that are shared or it's the additional learning spaces, the more we can put outside the bubble, the smaller the area that we're actually gonna have to condition, especially in the face of power outages and others. This is a study that was done on 14 schools in Georgia where they looked at children's schools and whether they had outdoor spaces. They scored them based on a rating system and found that there was substantial improvement in children performance the more outdoor learning space they had and the more diverse those spaces were. The term biophilia was coined by Eric Fromm many years ago and then sort of codified by E.O. Wilson at Harvard and Stephen Keller at Yale in a book called The Biophilia Hypothesis that basically said humans have an innate need for connection to living things, that we thrive on that connection. And nature holds the key to our aesthetic, our intellectual, our cognitive, and even our spiritual satisfaction, is what E.O. Wilson wrote. So biophilia is basically everything I've been talking about in terms of the natural technology. It's views, it's daylight, it's solar heat, it's natural ventilation, it's access to nature. And beyond that, it's things, and we have research on those, but we don't have as much research on, do we have to hear the sounds of nature? Do we have to have the sensory feel of nature itself? Do we have to walk barefoot in the grass? Do we need to understand what natural materials are? Does it matter if this wood is a plastic version of wood or is real wood? Does it matter to us, to our inherent needs? The importance of craft and the human hand, and art and the human hand. The importance of being able to be visually and physically and acoustically linked to the community, to hear kids playing on the playground or listen to tennis balls going back and forth on a tennis court. Those are all elements of living, animated things that turns out to be very important to our human health. I want to close by saying, at this point, I really think the profession is way ahead of academia. The architects are already working in teams. They already have a group of landscape architects who are leaders in water and heat and gray water and black water and all the things that we need to process, and the notion of outdoor learning and outdoor living that we need to have on the team as we start. They've already got a group of engineers who know the word mixed mode, who are already designing so that you can rely on natural ventilation for as long as possible, and passive cooling for whenever possible, and passive heating for whenever possible, and only turn on the mechanical systems as needed in only the spaces that need it, not in every space. I don't need my fire stairs, which at Carnegie Mellon, the fire stairs are hot. I mean, we've got steam running all over our campus, and they've no control. Their valves have been dead for a long time. Those fire stairs are like saunas. I'm thinking, what are we doing? Why don't we just turn the whole thing off and let the fire stair float? This is the Candida Center at Georgia Tech. It was the first living building in Georgia, so it met the living building challenge, which it means it's net zero energy, net zero water, net zero land, so they're using brownfields only, and net zero waste in construction. So they're literally going for net zero across the board. It's Lord Eck, Sargent, and Miller Hull were the architects, Andrew Pogan were the landscape, PAE Engineering were the engineers, Biohabitats again, Skanska was the construction. It takes a team to make these projects. These buildings have been done now, zero carbon buildings have been done in every climate in the US by taking very, very small energy use intensities. The kBTU per square foot are tiny in these buildings. This particular one is I'm going to say, it might be 35 kBTU per square foot, which is not as tiny as it could be. And then they meet that load with on-site or community adjacent PV. In this case, they made it on-site, which is why the PV panels are as large as they are, is because they're meeting the entire, in fact, they meet more than the load of the building. And they have made this a carbon positive building. Also, it's a cross-laminated timber building. So they've completely addressed the embodied carbon challenge. It was 30 kBTU there, I wrote it down. It has nested thermal zones. They're not conditioning all the spaces to the tightest thermal requirement. Where you sit in a classroom, you need a tight thermal environment. When you walk from a classroom, you don't need a tight thermal environment. The PV is 200% of the demand, so it meets double what it's needed for the building itself. It has a lot of outdoor classrooms. It has outdoor dining. It also has, the entire roof is an accessible roof, so they have roof gardens, and you can sit out there and have lunch, and it's an amazing building. Every campus needs a Candida building, right? Candida was the foundation that paid for the cost differential to make a building that was net zero and living. And with that, I'm going to close and answer questions. So.
I think you delivered on your promise to give us a lot of information in a very short period of time. That was fascinating. We'll open the floor for a few questions. Who would like to go first?
How many of you guys have heard the word mitigation and adaptation before tonight? Lots. You guys are good. That's good.
Thanks, Vivian. I come from purely on the embodied carbon side of things. And, you know, when we and my peers discuss these kinds of things to practitioners and to, say, large industry partners, and talk about these, you know, quite obvious things to do that we can do to improve the state of our structure and our built environments, there's been, I'm just curious if you could talk, you know, you mentioned multiple times that industry is ahead of academia, and you've given really nice examples of this in practice and built examples. How many of these were kind of, you know, inherently demands from the client, and how many of these projects were, you know, really concerted efforts from the architects and engineers and these teams to convince people to, you know, do these practices? Because, you know, you could imagine if that upfront costs, and you gave those university examples, those upfront costs, no matter what the projected savings are, it's hard to convince people to actually apply these things. I'm just curious, especially in the built examples that you give.
So every one of these projects is only as good as the weakest link in the team. And sometimes it's the contractor that's the weakest link, and sometimes it's the architect that's the weakest link, sometimes it's the engineer, and sometimes it's the client, right? So You can find a lot of innovative projects that don't make it very far because there's a weak link in the team, which is why a lot of these firms have formed alliances with like-minded professionals, so they don't hit a weak link, and they don't have someone speaking up in the meeting in front of the client and say, well, it's going to cost you a little more, because as soon as they do that, the client goes, oh, no, I don't want to do that, right? So I do think the profession is ahead of academia. Now, I'm showing you leading professionals, right? I'm not saying that every professional is ahead of academia. But the leading firms that are literally, any firm that literally as a firm states that sustainability is their goal, firm-wide, not just we've got a sustainability team that does one project every 50 projects. We as a firm, I just got from Boland Twinsky Jackson, which is originally a Pittsburgh, Wilkes-Barre, Pennsylvania-based firm that's done beautiful projects around the country. They just sent out their latest strategic plan for sustainability, and it's just brilliant. It's so beautifully written. So these to make it work, you really have to have a team. Do I think that every firm is at the same level? No, but I think the leading firms are way ahead of us. Industry is an interesting question, though. If you look at industries that are leaders, they do care about embodied carbon. They do care about operational carbon. Probably the most compelling story was Interface Carpet, the largest manufacturer of carpets. Ray Anderson was 65 when he discovered green and sustainability. 65 years old, all of a sudden he was overwhelmed with the idea, wait a minute, I'm producing a waste product that goes into landfill all over the world, and it's actually a raw material that I could use. And he literally, from the natural step, which came out of Sweden, trying to convince executives of industrial production players to care about sustainability, and the natural step basically said, you need to treat every one of your products as a commodity in your next product. And so he changed the entire operation of Interface around sustainability. And it's still a leading, I mean, I did a whole POE on their new headquarters, which is in an old building in Atlanta, with mixed mode in Atlanta, which is impressive. A very interesting project. So I do see that there are industrial leaders that are absolutely trying to overthink, to overwhelm or overwrite the way in which they've done businesses in the past in order to really set all of the operational and embodied, and not just carbon, but water and materials, raw materials, and make sure that things start to close loop. So cradle to cradle is probably the best term we could use to capture that notion.
Great, other questions?
Thank you. I have two questions, actually. It's fine. The first one is mainly about the operational carbon, like assuming buildings are electrified, right? So now you have to make them more efficient by fixing one household at a time, versus if you could build a wind farm, a solar plant that fixes one.
Let me answer your first question first. Let me do this, because this is really important. Electrification is literally sweeping, I mean, everyone is trying to electrify because we can do renewable electricity with wind and sun. But we do not have enough wind and sun to electrify America's buildings. We are not even close to being able to do that, right? So there is a plan to electrify all of America's buildings. Right now, what they're going to electrify is everything that runs on gas and oil, right? It's all the fossil fuels that we're trying to get out of buildings. If you electrified all of those, your energy bills would double. Just be careful, because electricity, even if I have 300% efficient heat pump, is a more expensive source for heat energy than gas, right? So ultimately, it's a more expensive source. I don't know if I said efficient, more expensive source. So you're going to end up paying for heating your house more than you're paying now. So it has to go hand in hand with efficiency. The efficiency means that you drop the demand for any fuel. And if you take a house and you achieve, even if you don't achieve passive house, you achieve a fraction of what passive house would do, you will drop the demand, and then, yes, you would electrify your heating energy source, which might also give you a cooling energy source with heat pumps. And the grid, up to a point, will be able to provide that electricity until too many of your neighbors want to switch over to electric. And if we start doing transportation, all electric, at this point we've got about 1% of our cars out there that are electric. It's still very small. But if we ended up having 20, 30% of our cars, all of a sudden the demand on the electric grid would go way up. And the electric world is thrilled about this because they're basically saying, okay, give us money, we'll build more transmission lines to every city. So they want to put lots and lots of lines across all the agricultural land and suburbs of America to get more to you so we can electrify our homes. They're not thinking about distributed PV on people's roofs because that's messy and hard to control. They want to have a big photovoltaic farm. Farm is sort of in quotes. They will take a farm and turn it into a PV, powerhouse, and then sell you electricity through a much bigger line. I think electrification is really important, but we have to be ready with conservation. As professionals in the architecture and urban world, we have to drop the demand by half, and then electrify. Not electrify and then figure out where we're going to get the electricity from. But, okay, that was your first question.
The second part was completely different. It's more about connecting humans. So we have knowledge, about building, making it more efficient. Don't turn on the window when it's freezing cold outside. So how would you involve, what's the gap there to involve average occupant or everybody inside a room, especially smart home? You're saying people are concerning about the cool factor that I can turn on the light off, set my thermostat to get comfort rather than saving energy. Do you think that is something on the background, not?
No, I think it's really important. All the cool factor of smartphone-based controls is a real contribution to efficiency if it's used that way, right? So ultimately, if I walk away, so we've done a lot of work on smart controllers that are iPhone-based or smartphone-based, where because there's a GPS built into your phone, you can basically schedule it to say, okay, all the following things that are plugged into my outlets can be cut off when I walk away from my desk, right? I don't have to do anything. I just literally walked away with my phone. There's a lot of capability that's built into the smartness. Of course, I can also stand there with my phone and point at the fixture and turn it on. I can even dim it, right, with my phone. So because gesture is baked into your smartphone, right? It's amazing. It knows the position and the gesture. So ultimately, we can do a lot. So all of those hot technologies can be for the force of good and not just play. I mean, they can be play too, but they can be the force of good. So I'm a big believer in taking smart controls. And the human, then, you can choose to either play with it all the time or just put it on auto with a logical, smart thermostats. I shut mine down every night to 58 degrees because I've got lots of covers. And I put it up an hour before I'm going to get up to 68 so I can have breakfast in comfort. And then I turn it down when I go to school, and I turn it up an hour before I come home. And I can just set it up and let it be, right? I don't have to play. But I could also decide to turn it to my husband's at home. So I could turn off his heat right now. He would not be happy, but I could do it, right?
All right, I think we have time for one more question.
Hi. I guess I wanted to add on to that, that question about smart homes, because I personally am skeptical of smart homes. I think it's very much a lot of talk and people are oh, this is so cool, this will solve all of our problems. And I was wondering what your take is on kind of the difference between changing, adapting systems so that people increasingly use this kind of smart home system to actually reduce energy demand, or the other way where you're shifting people's perception of how to interact with their environments, shifting this culture. What is the balance between that? And should they be in parallel, or do we go one or the other, or
One of our PhD grads, who's a faculty member at University of Minnesota, Malini Srivastava, did a PhD specifically on energy gaming. and what we have to do, both at home and in schools, to make energy conservation an inherent part of everyday life, right? And she created a whole series. Some of it is just getting a score at the end of the day, right? And NEST does that. They actually send you a monthly report and say, this is how you're in the top 20% of your neighborhood with NEST thermostats, or you're in the bottom 20%, right? And they're trying to incentivize you. So sometimes we just need to be reminded because we don't remember how much we've used. I've had another PhD student who did a thesis on lighting system controls, which gave you not only a controller online, but it also gave you recommendations that you could say yes, 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 or no, no, no. And it gave you a carbon score. And she found that when she just gave the controller without recommendations, it saved energy because people used it. When she gave them recommendations, it increased the energy efficient savings. And when she gave them recommendations and a carbon score, it increased it even further. So she was able to show over time how you can turn those smart control ideas into something that really is achieving the carbon neutrality that we want to have. So yeah, for a long time, we're probably going to see more toys than we see. LED actually scares me because LED was a massive improvement in conventional lighting, but for architects and designers, it was like a free-for-all. Now I can put lighting everywhere. I mean, I can have zip-zap, lighting running in every direction, total visual chaos, very hard on the human eye to cope with that bright line and zigzagging across the ceiling when really what you needed was light on this surface, right? So I think we're going the wrong way because we're tripling, quadrupling the amount of light we're plugging in. But it's 10% of the demand of the old light fixture. So we've got a little bit of room. It's just sad that we've used this as an excuse for, so yeah, it's an interesting question about how we take, as you can hear from my talk, I'm extremely interested in the passive side. What can we do to let nature run the building? And then just in time, find the active side rather than the other way around. Let's make the active more and more efficient and then figure out whether we're going to let nature in at all. I really think we have to design around nature. So maybe to end with, nature matters. Humans have to be active. It's like surfing. You have to be actively involved. You can't just say, nature will give me perfect daylight all the time. No, it's going to give you glare sometimes. It's going to be too dim. It's going to be too bright. You're going to have to, which is why I love Venetian blinds over mesh shades. Mesh shades are lousy daylight. They literally, and they're terrible for views. They basically say, okay, too much glare, I'm going to close this, and then people never open it again. Whereas with a Venetian blind, you can drop it and tilt it so you still have a view out and it gives you the shade. So we need to maximize how daylight is used in spaces, and then we'll figure out the smart electric, yeah. So anyway, okay.
Great. Well, thank you for a fabulous talk and a stimulating